So this is an experiment we were actually running on the northern part of the I-275. What you can see in the top, in this case, we were using only vehicle-to-vehicle communication. So we had a leading vehicle, which was a few vehicles ahead of the follower vehicle. Both of these had connectivity. I will talk a little bit more about the technology in a few slides. And so that means that the vehicles were able to talk to each other, okay? So let me show you what happened in one of the experiments. So this was around this section of the highway. And you can see the leader is going to talk soon. That there is a traffic jam which is hitting. And very soon after that, the follower is also slowing down. As a matter of fact, in this particular case, had to stop. As you can see, the driver is reporting something very crazy happened here. Actually, some of the vehicles had to go to the shoulder. So indeed, this was an interesting event. As a matter of fact, there was no accident. There was no particular reason. It's simply how people drive. In this case, the effect of the leader, which he was reporting, is actually got amplified, and that's what the follower has seen. Okay. So this shows that indeed, understanding what the vehicle ahead is doing is going to help the follower to understand what is up to happen to him or her. So let me try to explain to you how does this work, okay, and why is it useful. So on the right side, you can see two trajectories of two vehicles driving in the traffic flow. They are not following directly each other. They are somewhere in the flow, okay? This is real data taken on I-275. And as you can see, I'm showing you the leaders as well as the followers trajectory, okay? And if you kind of keep staring at this picture, you can realize that, well, the leader and the follower is not doing something that different. Actually, you can see these wiggles somewhere here and there. It looks like they somehow repeated by the follower. And as a matter of fact, this is exactly what happens. So if I consider the current time, as a matter of fact, I can take some section of the leader's profile and then propagate in this prediction zone, okay, which comes out of the equations where exactly is the zone is at. And based on that, I can provide a prediction of what the follower is going to do. Okay, so again, if this is now, then nothing happened, which is dashed here, okay? So because we collected the data, we know what is up to happen. And I'm demonstrating here is actually not really a bad prediction. You can also see it pretty well when you are showing the speed prediction. It's capturing reasonably well what is the follower up to do, okay? The trick here is you don't just have to shift things in time, you have to shift things in space and time. So what I'm trying to say is that essentially the follower is going to do something very similar to the leader, sometimes later and somewhere else on the highway, okay? And on the left-hand side, actually, you can see an animation which is done by the BBC a few years ago, where as a matter of fact, you can see how this jam is propagating back along the highway. And typically the speed of the jam is going backward is about 15 miles per hour. As a matter of fact, that is nothing else but the gradient of this prediction zone, okay? So, excuse me, as the vehicles go further ahead, indeed, the prediction zone changes. So as I go further, you can see now this is the present time, you can see the prediction zone, and you can also see how well, in case of the velocity, we are actually capturing with a very, very simple model, qualitatively capturing what is going to happen with the follower vehicle. Okay, so as a matter of fact, this is a nice moment because the follower vehicle at this point is traveling with a relatively high speed, but what is up to happen that this speed is going to break down to almost to zero, and after that the vehicle is going to accelerate back. Okay, and as we go further ahead, we can keep doing these predictions, and actually some of these are summarized in the paper which you can see on the left. Okay, so this shows us that there is a particular zone where we can provide predictions, and as a matter of fact, how wide this zone is also changing, and the width is of course matters because the wider the zone is, the longer the predictions we can provide. If I go back between the last two cases, you can see the width of the zone changes quite significantly. This depends on two things. It depends on the speed of the vehicles, but it also depends on how far they are from each other. The further they are, the more predictions I can have. The challenge is, of course, at some point, I'm going to hit the range of this communication, and then I won't be able to say anything, okay? So in order to make sure that we understand what is this range, we actually went and did many testing on I-275 already with this configuration. I think we have about 20 hours of data already. And based on that, we have found some interesting things.